Hello everyone. So as a part of this introductory neuroscience and neuroinstrumentation course, I'll be giving the next demonstration about MMN. I'll just give you how to do the EEG lab and ERP lab analysis with an MMN data. So I will be giving you a brief introduction about what is this MMN and how it looks and everything. So MMN, it means it's called as the mismatch negativity. It's actually a negative component that has been obtained where during the analysis, during the ERP analysis, EEG analysis. So we are actually giving two types of stimulus. Two stimuluses are given at a stretch, like standard of 500 hertz and a deviant of 1000 hertz, and that too it is in it's repeated in a particular fashion. For example, it will be always in this fashion: beep 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 boops, like that it will be. So it almost every time it will be in this fashion only, because it should be in a repetitive form. That's when we can find out when the deviant response is obtained. So the brain, what it does is it keeps the standard. Okay, the standard, it will think that okay, this is the the sound will come, and suddenly when there is a difference in this in the tone, that is when the deviant response is obtained, there is a different negative component that comes into part. That is called as this MMN, that mismatch negativity. That is why it is known as mismatch negativity. This is also similar to that of the auditory stimulus, auditory evoked potential itself, because even in this also there is a the auditory, because it's the auditory stimulus we are giving, there is an auditory cortex is it is involved in this particular MMN ERPs also. So usually this MMN, if you see, if it will be always between 150 to 300 millisecond. In this particular range, the MMN should be seen every time. So it starts with the deviant stimulus. It starts soon after there is a deviant stimulus obtained, there will be this MMN response being obtained. Next, so experimental details, it's again recorded from the NeuroScan system, a wet electrode system. So here we have the it's a 64 channel again, and then we have the stimulus. As I told you, it should be this it will be standards and a deviant, and followed by 4 standards and 1 deviant, like that. This will be repeated for about 100 loops or something like that. So we will get a huge, and the time range of this MMN, it would be maybe it takes about 10 to 15 minutes, like that. So then only we will be able to average all the ERPs and everything and to obtain the particular MMN. And even in this also we have all the filtering range. We will do all the filters. We will be incorporating the notch filter, the band pass filter and everything. And the artifact rejection is again from minus 100 to plus 100 microvolts. So even in this experiment, what happens, we have a longer time range. We are having more I mean, it's taking 15 minutes of we can't steadily or stationary like that, we can't sit for long. So obviously there will be a lot of artifacts being produced in this also. So that is why we have to have the artifact rejection to be done in all the ERPs. Yeah, and this mainly the MMN, it has been obtained in the frontal right frontal part of the brain. It will be obtained. So for example, I'll just show you in the next picture. So here, this blue part over here, that is the place where the MMN response is maximum, because here is the place where you have the primary and the primary and the non-primary auditory cortex and all are present in this part of the brain. So here in this place only the MMN has been obtained. So here in the first figure, as I showed, here we have there are 3 standards followed by the deviant stimulus. So what happens is all the standards we can together average it and obtain one waveform, and all the deviants together we can average it and produce this waveform. The thin black line over here is the standard stimulus waveform, and the thick line over here, that is actually the the deviant stimulus. Okay, so that is a waveform obtained for the deviant stimulus. Now what we have to do is, always in this MMN, it should be the difference between, there will be the MMN is not, it's not just the deviant stimulus or the standard stimulus, it's not that, it is the difference between the deviant and the standard. So when we do so when we have this ERP analysis been done, we have to separately bin we have to create two different bins for the standard as well as the deviant, and then we have to subtract we have to do a bin operation, so that there will be a subtraction taking place between the deviant and the standard. So then only we will get the proper MMN result. So here in this case, here it show, in this figure it is shown, and in the left figure it is shown as a negative down or a positive up as shown. So here if you see, it's a perfect peak at the 200th millisecond, and over here we can see that it is between 150 to 200, you will have 100 to 200, there is a peak. This is a two different pictures I have taken just to show how which part of the brain has been activated in this case, and what is the different stimuli, how does the stimuli looks for that part. We are using this. So always the standard will be a 500 hertz tone and a 5000 hertz tone. Now there are various types of MMN also, like there can be duration MMN. For example, now from one deviant, from the standard to deviant, if you have, we can change the time frame. Now usually sometimes mostly people take a 500 millisecond difference or a 2 hertz of frequency they will take, in that range they will do the experiment. So sometimes they will take a different time frame also. So there are different types of MMN also been there, like this duration MMN and the delta MMN, like that. There are various types of MMN is also there. We can modify the experimental protocols according to what we want to find out. So different types of this one will have, obviously will have different kinds of result also. So this is about the MMN pictorial representation of how it looks. And so how does and I'll just go a brief about how to do this MMN demonstration in EEG lab and ERP lab. So again, as I told you, first we have to have the format according to the EEG thing. I mean, whichever EEG format we have, according to that we have to get, and then we will import the EEG data, and then we do the per-notch filtering, and followed by we just check which trigger refers to the standard and which triggers refers to the deviant. We have to check that before doing any analysis, and then create the event list for the standard and deviant separately, and then we have to do the artifact rejection, all the band passing filters and everything, and then finally we have to epoch the MMN. And we have to do another important step apart from the AEP is that we have to do the bin operation in this thing, because we wanted, the MMN is actually the difference between the deviant and the standard, so we have to do that particular step in the ERP lab analysis before doing any other. Otherwise we will just directly, if you don't do the bin operation, we can just visualize the standard alone and the deviant alone, but we won't be able to visualize how the MMN looks. Even the channel operations also can be done for this particular, because as I told you, only the right side frontal central, in that particular area only the brain is being activated, so only those electrodes and all can be together averaged, and channel operation can be done averaged together in that part, and then we can obtain a final MMN waveform. So this is about the total, how the procedural of procedures of what we have to do in the EEG lab. And the MMN, if you have to say about this is the proper, like this Natanen is the main person who actually done a lot of research on this MMN, various other different types of MMN, auditory, visual, or even this duration MMN. As I told you, different types of MMN and analysis has been performed by this Natanen and group. So these are the best references you can give for MMN, you can have this as the base paper for doing any MMN analysis. So the next I will just go about the demonstrating how does the MMN EEG lab, ERP lab analysis we can do using the MATLAB source. So thank you.